Just imagine you could travel near the speed of light. You're sitting in your ship, engines humming, stars stretching into streaks. To you, it feels like acceleration, but something strange begins to happen. The space in front of you starts to shrink. The distance to your destination, maybe the Andromeda galaxy, compresses like a folded map. That's relativity at work. The faster you move, the more the universe itself seems to make room for you to get there. Andromeda is about 2.5 million light-years away in Earth's view. But from your frame, that distance melts down. At near light speed, you could reach it in what feels like minutes. That's because your clock, every atom in your body, every beat of your heart, slows compared to Earth's. You'd see galaxies sliding by in moments. For you, it's a quick trip across the cosmic ocean. For Earth, it's still a voyage of millions of years. If you ever turned around and came home, you'd find a different sky. Every mountain worn down, every language gone. Civilizations risen and fallen while you only lived a few hours. That's the price of moving close to light speed. Your personal time stretches, but the universe keeps on ticking. Now let's talk about the twin paradox. It's not science fiction, it's a real consequence of Einstein's equations. Imagine two twins born on Earth. One stays home, the other boards a rocket and leaves for a nearby star. They promise to meet again after the journey. As the ship speeds up, each twin sees the other's clock slow down. That's the symmetry of motion. But the moment the traveler turns around, something changes. That turnaround breaks the symmetry. Because while the twin on Earth stays in one frame of space-time, the traveler switches frames, flipping from outbound to inbound. And that switch makes all the difference. During that moment, the traveler's sense of, "What time is it on Earth right now?" jumps forward. In seconds of ship time, years pass back home. That's the relativity of simultaneity, a phrase that sounds abstract until you realize it means this. The very idea of now depends on how you're moving. So when they finally reunite, the space traveler is younger. Not by illusion, not by some clock error, truly younger. Their body, their atoms, their time itself ran slower. If the trip lasted 10 Earth years, the traveler might have lived only 6. Go faster and the gap widens. At 99.999% the speed of light, you could live a day while Earth races through centuries. The twin paradox isn't really a paradox at all. It's a mirror held up to what time actually is. Not a universal flow, but something woven into motion and gravity. Two people can live through the same story and age at different rates, and both are right. But here's the question almost no one asks. What happens after you stop? You've been gone what feels like a few hours, maybe a few days. You hit the brakes, your ship slows, and suddenly, the light that's been chasing you catches up. You look out the window and see the impossible. Stars whip from streaks back into points. But then, they start to move again. Faster than seems real. Galaxies spin, suns explode, nebulae bloom and vanish. In the span of minutes, you're watching the universe age before your eyes. Because while you were outrunning time, it never stopped flowing everywhere else. Back on Earth, you were gone for millions of years. Every trace of you erased by evolution and weather. Maybe no humans remain. Maybe no Earth remains. You left the world you knew and returned to one that can't even remember you. That's what traveling near light speed really means. It's not just a trick of physics. It's a one-way ticket into the deep future. A way to skip ahead through history while your own clock barely ticks. A traveler's dream and a human tragedy. You'd be both explorer and ghost. A visitor to a time where everything you loved is gone and everything familiar is ancient dust. You'd see the future, but you could never share it with the past. And yet, there's beauty in that thought, because it reminds us how fragile and precious our little slice of time is. We don't need to travel near light speed to feel how fast everything moves. Look around, children growing, cities changing, stars dying quietly overhead. Relativity isn't just about rockets and equations. It's about what it means to live inside time. Einstein showed that space and time are the same fabric. Stretch one, and you stretch the other. And in a way, that means every moment we live leaves a permanent thread in that fabric. Unrepeatable, but real. So maybe the real paradox isn't that time slows down when you move. It's that we move through time at all. Always forward, never back. Every second, light speed or not. And if you could see that from above, if you could watch humanity's brief spark from the edge of the galaxy, you might realize something. We already are travelers through space-time, just very slow ones.